Welcome to Ox Tools. For those of you who've been following the series, I'm Tom. We've been working on this heavy-duty steady rest for a while now, and we're getting down to the wire here. Last couple of little details on it. I made a hinge for it. I didn't make it on camera because it's pretty straightforward. It's just kind of straight milling and drilling stuff, nothing fancy. That's back here. And I'll have some close-up pictures of this stuff so you guys can see it. And there's the hinge back there. I still need a shoulder bolt that's the right length to finish that off, but I had one that was a little longer. So, and then we made this knob the other day, this fluted knob with the latch bolt. So what we're doing today is I need 3 knobs here for the adjustment screws for these, and then I need some special studs here to lock these once they're in position. So I was going to make them out of bronze, but I checked the scrap yards and my usual supply joints, and I couldn't come up with anything. I have a little bit, but I don't have enough to make 3 knobs. So I decided I'm gonna make them out of steel. I have some, my friend Marty gave me some 8620 rod in a couple of flavors, diameters. And this machine's real nice. I can get it black oxide coated at some point if I'm sending some of that out. And what I'll do is I'll put a bronze washer underneath it for kind of a wear surface, so it'll behave itself properly there, or even just a good plated steel washer. So anyway, we're going to make a couple of knobs. I made a little chicken sketch based on the amount of material that I had available, and there's the sketch there. I always like to start with a sketch. It just keeps me from having to think while I'm on the machine, and kind of keeps me going in the right direction. And this will get incorporated into the design on the computer at some point. So anyway, we're going to go ahead and make some knobs, and I'll either set screw them or pin them or something like that to contain them on these shafts. And then what's left in there? Oh yeah, the studs, and then some finish work. I probably won't show the finish work. It's just a bunch of grinding, and there'll be a bunch of grinding and chamfering some of these edges, and then at some point some paint. I'll probably save up a batch of paint work for powder coat. That way I get a kind of a better price per piece when I take it to the powder coater. It would be nice to paint this, so I'll either spray bomb it or get it powder coated later on. So anyway, that's what we're going to do today, and we'll change the camera around, we'll get in close and look at these knobs that we're making. Alright, so we're going to go ahead and do another one of these knobs here. We got a couple done already. We'll do a couple more. I got the camera in a little different spot. I'm hoping it'll be a better spot for you guys. That's set at the 0. Something like that. Okay. It's a facing operation here. Face the front off. So that faces it off at Z0. Now what I'm going to do is I'm going to move it in to the first turn shoulder, which is at 625, right? And I'm going to make a little mark there. And all that is just a visual witness mark for me for when I'm roughing. I can, I got a visual cue there that I'm getting close to my number. So when I get close to that line, disengage the feed, and then look down at the travel dial and hand dial in the last little bit. Okay, so something moved on me here. I don't think I had this quite tight enough here. Let's crank that down a little more. It's a little bit of feed pressure on there. So we'll go back and reestablish our zero. I pushed into the chuck a little bit. Okay, so we'll reface it. The piece is getting kind of short, so I don't have a lot up inside the chuck. That's probably one of the problems. Alright, let's do that last cut. Okay, now we're happy. Kind of back on the game again. Okay. And this should be the finished pass here. There's my shoulder. Then I come out and face out. Okay, so diameter and shoulder. Get that out of the way. So chamfers. Come up and drill. Alright, I'll zero my, I don't know if you can see this over here. Let's turn this a little bit. I got this indicator here set up to measure depth. I don't want to drill, I don't want to over drill this here. Back up here. 750 right there. Try that again. Ran out of indicator travel. 200. 300. 400. 500, 600, 750. Okay. Get that out of there. I don't need that anymore. Alright. So what I'm going to do now, and you can't really see it from your angle, is I'm going to chamfer the edge of the tap drill hole here so it just taps easier. Okay, let's get that out of there. Shift to low range. Let's see. That's probably good. Little lube. Now, I'm not tapping it very deep. It's just enough to keep everything straight. I'm going to go until the tap spins. Right there. Okay. Come back out. Okay, that gives me about a diameter of threads in there, which should be plenty for what we're doing with that. Okay, so where's my there it is. This camera's right in my way here. Oop, shit. Hey, you know what? Filming and machining can be tricky, guys. I forgot I didn't turn that diameter. It's just a light cut, but still want it. So that establishes the diameter. Yeah, chamfer's close enough. I'm not going to mess with it. All right, and this is the scale dimension here to get it close to 1 inch. That's the overall length. So we'll go ahead and part that off now. Alright, getting close to the bottom now. Good. Alright, in this setup, we're facing off the back side of the knobs that I just parted off. So what I'm going to do here is I'm going to use a piece of 1/1000 shim stock, 25 micron shim stock, and I'm going to zero the tool on the chuck jaw. So there, it just grabbed it, so I know I'm 1 thou off of that. I'm going to zero the travidile here, and then I'm going to come out 375. So that'll be my finish rim thickness there. 375 thousandths, a little less than 10 millimeters. And so I'm re-zeroing the travadial here. And what I'll do now is just face this off. Get that little parting pip off of there first. If you're not careful with the parting pips, it can chip your tool pretty easily. Actually, shift the finished thickness there. So I don't need to go all the way in because I'm going to do a little relief in that surface. So we come up and add the chamfer here. 10, 20, 30, 40, 50, 60. Okay. Now I'm gonna, nope, that's not it. Right there. Okay, so I'm gonna dig in a little bit and then face off. So I'm adding a little cup-shaped relief on the surface there. It's just decorative. It doesn't really serve any function other than makes the knob look a little better. Oh, it's just a little step in that. It just makes it look a little better. So now we're going to go over to the mill and put some flutes around that outside edge and a set screw hole or something on the side. Alright, so I decided to do the flutes a little different on the rims of these, just for fun. So we're going to use this little 5C indexer here, and just hold on to them like this in the indexer, and then we'll just go ahead and index them that way, instead of doing coordinates or something. So back to 0. But first I got to pick up the center line. I got a 1-inch gauge pin here. I'm just gonna stick that in there and use the edge finder here, you know, kind of normal fashion. Alright. Get on center. Half inch. Shake. Okay. Okay, so let's get this out of there. We'll put our first victim in there, like that. Secure the collet. So I'm going to use a ball end mill here, and I'm just going to cut partway through the rim and leave kind of a rounded bottom. I've done this before. Looks a little different. For small knobs, it's kind of cool. I'll probably do, I don't know, 12 divisions or something like that. And so let's come up here. I'm just going to touch off here. Alright. And let's drop down, say, 60 thousandths. What do you think? 60? Does that look about right? Sure, let's see what it looks like. We can always go. Oop, that wasn't 60. There's 60. We can always go a little deeper, and we'll see what it looks like. I can tell you I don't like the feel of that. I'm gonna get my trusty lock wrench here. I got a little O-ring under that. Let's try it again. There's a little seal O-ring under the lock bolt here. It's annoying me now. Alright. Well, I think it'll come off easy now. Get that out of there. Come on. There it goes. Theoretically, this should lock. Well, what the heck? Where's my lock bolt? Alright, Mr. Wizard. Huh. Interesting. My lock bolt doesn't lock. I wonder why. Alright, let's fix it. Alright, well, my friend Charlie gave me this this indexer, and I've never used the lock bolt on it actually in all the years that I've had it. Mainly because I probably just used it for drilling and stuff. Anyway, he shortened this bolt and put an O-ring on it to kind of seal it up, because you can see it has a pulley on it, and he was using it as a spinner in his surface grinder. So I just popped a couple of slugs, copper slugs, out on the punch press over there, and dropped them in the hole to act as a, you know, he machined that bolt down a long time ago, I guess. But so now it locks. I can secure it, and this thing won't vibrate when I machine. As soon as I started to cut that, I could feel the whole thing shaking a little bit, so I backed off. Anyway, let's try it again here. That's 60 deep. I'm on 0, and we're gonna go up. And the idea is that I'm going to create these kind of rounded notches that don't quite go all the way through that rim. See how that looks. Oh yeah, it's not bad. I'm going to go a little deeper. Let's go 75. See what that looks like. Okay, let's go for that. 75 deep. Alright, and I'm going to do every 30 degrees. There's 30. Lock again. Alright. Well, it feels pretty good. Yeah, you know what? I think I want to go deeper than that. If I take it out, though, you know, I lose my positioning there. Well, it feels pretty good, but you know, I'm gonna do a little sanding on that to smooth it, and if I want a little more purchase on that. But oops. Well, you gotta think about that for a minute. All right, so I went back around it again a little deeper, and I like the feel of it here. And when I round this off a little bit and deburr it with some paper, it'll probably have the right feel that I'm looking for. So I'm pretty happy with that. It's kind of a castellated look, I guess. I'm gonna pull that out, and you can see that. Do a little sanding on that and clean it up some, and oops, ouch, and we'll have some knobs. Well, I cut the notches a little deeper, and you can kind of see that, and then I deburred it and sanded it a little bit, and to be honest, guys, I don't like it. It sucks. It's too busy. It doesn't look very good. I'm not very happy with it. Now, I didn't do the other two here. I just did the one, so I'll remake the one probably and do something else. But I'm not happy with it. I mean, you know, it's a good gripping surface and all that, but it doesn't really. It's not working for me, okay? So it's kind of hard to explain. It doesn't go with the motif of the steady rest, and I'm kind of not pleased with the proportions here. So it's a subtle thing, and I just don't like it. So I'm going to do it again, no big deal. Some of you guys, they're out there screaming, why doesn't he just knurl it? Why does he just knurl it? Well, I don't have a knurling tool here. I have to borrow it from work when I want to do some knurling, and I wasn't thinking that far ahead last week. So you're right, I could knurl it and do something like that. Although, I don't know, I want to do something special, simple but special, you know, and have it kind of match. And and go with the thing. I don't want to make them a bunch of times just to satisfy myself. So anyway, I'm going to go think about it a little bit, and or work on something else and let this kind of stew in the back of my head a little bit, and I'll get an idea and fix it up. So I mean, I don't know, smooth actually is not too bad. At one point I was thinking about having a hex on here so that I could turn it with a socket wrench or something like that to move it a long distance. So I'm going to go back and revisit those things and see if I want to change my mind here. Okay. Well, I got vetoed on the knobs. My artist wife liked the look of them. I'm not super happy with them, but they'll be okay. So we're gonna go with them. So let's just doing some final assembly here, and there's the knob, and get in a little closer there. You can see here there's a bronze thrust washer, and then there's another one under here, and then there's a threaded collar, threaded clamp collar. So what that does is that clamps, it sandwiches this end piece, so it does a push and pull with the thread. And when it comes up, it's bearing against the internal thrust washer, and when I'm pushing down with it, the knob is bearing against the external thrust washer. And then what's neat is I can adjust those and tune that space so that there's no backlash basically, but it still turns free, and that's the idea there. So that's a little push-pull setup there. You know, it's just the subtlety of the design. So anyway, then that goes on here like so, and it takes you about half an hour to wind it down there, which I'm not going to do right now. So what we're going to make now is there's let's see, you can see here. There's a couple of things. There's these threaded holes right here, and when I changed the design early on, I had to change this locking stud arrangement a little bit. So we're going to make there's some little short studs with a mount on the bottom. They go to here and project through here, and then there'll be a nut and a washer out here that actually locks that roller arm in the desired position. So we're going to go ahead and make those now, and then that's kind of it for the mechanicals on this thing. And it's just finished work. I still need a shoulder bolt, and which I ordered, and what else? And then some paint and perhaps some welding to weld the main block to the frame. But that would be after sandblasting and detailing work. So let's go ahead and make those little stud guys, and get them on here, and you know, wrap this deal up, eh? All right, so we're cutting off some pieces over here in the vise, and now I have a horizontal bandsaw. I don't know if you guys have seen it yet. I haven't had it that long, but I bought it used, and so I use it for cutoff of the heavier materials. It has a rather coarse tooth blade on it, so I kind of leave that set up for efficient cutting on heavier, blockier materials. And then what I do a lot of times on small stuff like this is I either hacksaw it if it's just one piece, or I have I keep this right near the vise here, a Milwaukee Portaband that's set up with a finer blade for cutting small rods and unistrut and thin wall tubing and things like that, so I don't have to swap blades back and forth all the time. And then, you know, I have a vertical bandsaw too that I use for generally heavier stuff. So these are the little studs here, and we'll face these off, and they get a little shank turned on them in the lathe. And then these, I already cut a few of them. These are these little key segments here that will be the base of those. So we need a couple more, and we're just going to use the Portaband to cut it off, just because it's quick and convenient. I bought that. I used to teach welding at a school in Oakland many years ago, and a guy came by selling some tools one time. He was hard up for cash, and he had some tools, and I bought this and a couple other things from him for $60. I still remember because it was a great deal, and I've been using it for years and years, and it's a great tool, and it beats hand hacksaw. Anyway, that's it. That's 6 of them. That's what I need. Okay, so then we're going to go over to the mill. All right, we're over on the mill now. And we're gonna mill the ends of these rough sawn ends off and mill these to length. So first step is just to clean one end off. And a viewer was asking the other day about mill operations on kind of repeat pieces like this. So we'll talk about that a little bit as we go along here. But let's go ahead and get one end done here. So all I want on this end is just a full cleanup. Just to clean that saw cut up. So I'm feeling, you know, there's a burr on one side, but I'm putting the side without the burr against the vise, or the fixed jaw. Alright, so I got the end of all of those cleared off, and yeah, I'm going to file that a little bit. So now, I'm just going to go till it cleans up. And then I'll take a measurement and see where I am. Alright, and let's zero that little monkey. Alright, 1 inch 329, and I can plug that right into the DRO here, 1.329 preset. Okay, and now I can work right to my number here by looking at the DRO, and those want to be 1.25 inches when I'm done. That should be my finished dimension there. $251. I'll buy that for $1. Okay, so I've got a good registration now. And this is the first side that I cleaned off here. I'm just taking the burrs off so that it sits in the vise good. Okay, so we're gonna drill and counterbore these now for some number 10 socket heads. So a couple things. I like stub length drills, nice short ones here, and what it does is it saves me a center drilling operation or a spot drilling operation for, you know, stuff that's not super critical. It's faster, it saves a tool change, and gives me pretty, you know, decent accuracy. You know, for fussy stuff or things that you're, you know, maybe you're drilling into the something that's at an angle or whatever, you're going to want to spot drill it. And but the lesson is not everything needs to be spot drilled. Now, if I was using a jobber drill, they're a little more flexible, so they behave a little bit differently. So if that's all you have is jobber lengths drills, then yeah, you should spot drill. It's just a good habit to get into. But one of the guys I learned from said, hey, get yourself a set of spot drills and stub length drills. Over the course of the year, you're going to save thousands of tool changes, which, you know, really translates into some efficiency. And you know, if you're doing, you know, threaded holes and simple holes and stuff like that, where the true position call-outs for the holes are not radical, then it works fine. Now, if you got really fussy true position, you're not going to be drilling and reaming for position. It just doesn't work. It's not accurate. You need to bore holes that have very fussy true position call-outs. Now, in this case, it's a counterbored hole, right? The screw or the pilot's slightly oversized, and the counterbore slightly oversized from the screw, so true position on that is not particularly demanding. So what I wanted to talk about just briefly was, you know, we've got 6 parts here, and so you got a choice, right? So what we're doing is we're making a little thing that looks like this, right? Got a counterbore, and it's got a counterbore, right? So we got to drill and counterbore each position, right? Actually, it has another hole in the middle too, but we'll get to that in a sec. So you got a choice. You can drill and then move the table over and then drill again, or what we can do is we can drill, remove this tool, put the counterbore in, and counterbore, and then move. You know, there's several combinations that you can do. So the question that this person asked was, you know, what's the right way to do it? Well, it's a little bit hard to answer because it depends on the part. Now here we have some symmetries that we can take advantage of. So these holes are located an equal distance from the ends. So what that means is we can drill and then we can swap the part around like that and drill again with no table movement. So the problem with moving the table is you have to land on those numbers, right? And you got to dial them in, you got to dial them in, you got to dial them in, right? So and you can see that was quicker than moving the table, right? So that's really the measure: is what's quicker? Is it quicker to move the table, or is it quicker to swap the part? Now in this case we can do that. Now let's say that these didn't have a symmetry end to end. Let's say it was a different dimension. So you can see though that if we have our parts here, right, that we can drill a hole, take it out, we can drill another hole. That's still quicker than moving the table and dialing in a number. So on a small part like this, that's easy to get in and out of the vise, okay? Now, if you got some big part like this, it's not quite as easy to get it in and out of the vise. You're not going to want to do that. And it also depends how many tool changes. So those are some areas that you can pick up time at if you got a bunch of parts to process. So we'll go ahead and process these kind of I guess it would be serial fashion, is what we've been talking about. So let's make sure I'm on the right numbers. So I'm going to start slow there. Okay. Now I'm not going to turn the spindle off just because I got a lot of vertical clearance there and I can just get out of the way. Let's slow that down a little bit. The drill's getting a little hot. Okay, so that's the drilling. Make sure that, yep, it fits. So when you use a counterbore, make sure you stuff it all the way up in the chuck. That way you don't lose your Z position. So I'm going to zero my quill readout here. I'm going to grab a screw. Alright. This is the double check here. Alright, there's 190. That looks pretty good. Get some of this junk out of the way. Boom. Okay, so 6 pieces, 2 counterbores a piece. All right, so we just made these little bits here in the mill, and then I did these in the lathe. And these are the studs, and these go together like this, and then they get welded together. So we're set up here to do a little welding, and we're just this is cold rolled, 1018 cold rolled, and then this all thread is 4140 or 4130 all thread, I believe. Anyway, I'm going to use some 70,000 psi steel rod here to put it together, and that should do it. I think that's those on the table that has a big heat sink to cool them off. And I'll belt sand the backside. And I'll bring you in closer for a couple of shots here. So yeah, let's try bringing it in a little closer. So I'm setting those up just slightly below flush there. Okay, so let's go ahead and put one of these on here. And you can see some of the gyrations I had to go through there. So that's an example of, you know, a decision cascading through a design and affecting a bunch of other parts. You know, it's all okay in the end, and you know, it's just a little bit of trouble there. Okay, and I got these nice acorn nuts here. Ba-bum. And then they're kind of stiff right now. I don't have any lube on there either. It's just kind of a trial assembly there. And then those, boom, lock everything in place. Yeah. Still don't like the knobs. My wife likes them, but I don't like them. She says, keep them, keep them. I don't. I'm going to find something else. Okay, well, anyway, I got a couple more to put on here, and that's about it. So I'm going to call this the last episode of this thing. I'll probably take some stills and put it up on the blog. That's got some close-ups of some of these areas here. A little hard to see on the video camera sometimes, especially with this one here. And then, you know, once I do get it sandblasted and put some finish on this thing, I'll have some pictures up of that. So anyway, for all you guys that have followed this all the way through, this is 10 episodes, I think, or 11 episodes. I try not to make them too long, but thanks for watching, and I hope you enjoyed it. And then we got some other stuff coming up here, and I'm just going to swivel the camera around here so you guys can get an eyeful. That's what we're working on next there. This is a big hand wheel for etching press that I'm building for my wife. Anyway, we're going to be working on that, and we're also going to be working on the drill press there. I got some belts on order. Those will come in a few days, and we'll get that back together and wired up and rocking and rolling. So, and yeah, there's even more coming. So stay tuned, guys.